As I told you before, whenever we are having virtual functions, virtual table will be created for that function, and through virtual pointer, virtual function will be invoked. This is what happens whenever you create virtual functions. If you are rewriting, then only the starting address of the function will be changed. If you are not rewriting it in base derived class, then the starting address of the function remains same, so that it will invoke base class function itself. Else whatever you have rewritten, that function will be invoked. This is how virtual functions will be called. Now we are having virtual pointers through which virtual table will be accessed. Whether the size of class is increased when we have virtual functions. Yes, it is increased, but not by the size of the functions. If you have virtual function in a class, okay, the size of your class will be increased by 2 or 4 bytes based on 32 or 64-bit compiler. For virtual pointer, this 2 bytes or 4 bytes is only for virtual pointer, right? If we have n number of virtual functions, also the size of the class will be increased only by 2 bytes, not by the size of the functions, right? And one more thing is, if you don't want virtual functions, just don't make it as virtual, which will increase the memory utilization by creating virtual table. Also, the overhead of invoking virtual function, right? Through we have to find the virtual pointer, then through the pointer we should point it to virtual table, through which we have to invoke the function, which is time consuming process and overhead on operating system. So better don't make all the functions as virtual. Whenever it is required, make the function as virtual function. Next we will move on to pure virtual functions. What is pure virtual function? When I have a virtual function and I equate it to 0, this means it is an pure virtual function. In the base class, we are creating virtual void show equal to 0. Now this void show function will be pure virtual function. Why this pure virtual functions, right? Whenever I have a pure virtual function, again the table pointer everything is created, right? But if I equate it to 0, you must redefine it in derived class, right? That means inside this class derived, you have to rewrite the definition of show function, else you cannot create the object of class derived. See here, we are having class B virtual void show equal to 0. I can't create an object of class base. This is called abstract base class. Whenever we are having pure virtual function in a class, that class becomes abstract base class. That means you cannot instantiate or you cannot create an object of that class. Whenever you derive the class, you have to redefine, otherwise again this derived class will be treated as abstract base class. So only for this derived D we are getting an error, cannot declare variable D to be of abstract type derived, right? So abstract base class. Now we are redefining that function in derived class as void show, right? Now we will create an object of D. Yes, compilation succeeded. That means I can create an object of class derived. This is how we need to create. When to use this pure virtual functions? When I just want the skeleton of the program. That means I want to write a program for creating the area of triangle, rectangle, circle. Okay. area, that functionality remains same. Then I'll make that area function as pure virtual function in the base class shape, right? In the derived class triangle, I will rewrite the area function inside which I will create the area for triangle. Similarly for rectangle, circle, right? The signature of the function will be same, but the functionality inside will be different, where we can use pure virtual functions. Without the area, triangle cannot be there. So you must redefine that area. That's where I will make that area function as pure virtual functions, right? Now we will end this session.